Ohm's law can be used to determine the electrical values in any common circuit, even though it may have a number of different loads. In order to solve such circuits, it is necessary to know if the loads are connected in series, in parallel, or in combination. When the type of circuit is determined, the proper formula may be applied, and the desired values calculated. If current flows through a resistance, the voltage across the resistance is equal to the product of the current and the resistance. For example, the voltage in the circuit is called the IR drop, and the IR drop in a complete circuit is equal to the voltage of the supply source. In the illustration, consider that the resistance of a power source is 0.1 ohm, the resistance of 3 loads are 50 ohms each, the resistance of one load is 200 ohms, and the source voltage is 240 volts. Where load resistances are connected in series, they are added together to determine the total resistance of the circuit. The values in the illustration are used in the text to solve problems with unknown values in a series-connected circuit. For example, to find the current, divide the total resistance into the voltage of the power source. The current in amps can be calculated as follows. In step 1, finding current in amps, I, which is the amperage, equals 240 volts, divided by 0.1 ohms, plus 50 ohms, plus 50 ohms, plus 50 ohms, plus 200 ohms. Based on this formula, I, which is the amperage, equals 240 volts, divided by 350.1 ohms, which equals 0.6855 amps. Therefore, the current in amps is 0.6855 amps. Notice, the voltage drop across any resistance of the circuit may be easily found due to the current being the same through each load. For example, the voltage drop in the power source can be found by multiplying 0.6855 by 0.1 resistance of service as follows. In step 1, finding voltage drop, Vd, which is the voltage drop, equals 0.6855 amps, multiplied by 0.1 ohms, which equals 0.06855 volts. Therefore, the voltage drop in the power source is 0.06855 volts. For example, considering the voltage drop in the power source, what is the voltage drop across each individual load in the circuit? Use values in the illustration and text. In step 1, finding voltage drop, Vd, which is the voltage drop, equals I, which is the amperage, multiplied by R, which is the ohms, or resistance. Based on the formula, Vd, which is the voltage drop, equals 0.6855 amps, multiplied by 50 ohms, which equals 34.275 volts. Therefore, the voltage drop in each 50 ohm load is 34.275 volts. For example, with a voltage drop of 34.275 volts across each 50 ohm load, what is the voltage drop across the 200 ohm load? In step 1, finding voltage drop, Vd, which is the voltage drop, equals 0.6855 amps, multiplied by 200 ohms, which equals 137.1 volts. Therefore, the voltage drop across the 200 ohm load is 137.1 ohms. For example, with a voltage drop of 137.1 volts for the 200 ohm load, what is the sum of all the voltage drop calculations for the circuit? In step 1, finding sum of voltage drops, Vd, which is the voltage drop, equals 137.1 volts, plus 34.275 volts, plus 34.275 volts, plus 34.275 volts, equals 239.925 volts. Therefore, the voltage drop across all resistances, at rounded up value, is 240 volts. In the illustration, using the known values in the series circuit, calculate the total resistance and total amps in the exercise problem. In step 1, finding known values, R1 equals 9 ohms, R2 equals 8 ohms, and R3 equals 3 ohms. In step 2, setting up formula, RT, which is the total resistance, equals R1 plus R2 plus R3. In step 3, applying the formula, RT, which is the total resistance, equals 9 ohms, plus 8 ohms, plus 3 ohms, which equals 20 ohms. In step 4, finding known values for current, E, which is the voltage, equals 120 volts, and R, which is the resistance, equals 20 ohms. In step 5, setting up formula, I, which is the amperage, equals E, which is the voltage, divided by R, which is the resistance. In step 6, applying the formula, I, which is the amperage, equals 120 volts, divided by 20 ohms, which equals 6 amps. Therefore, the total resistance is 20 ohms, and the current is 6 amps.